Alright, so let's take a look at primates. Before we start talking about primates, let's look at the reasons of why we study primates. If anthropology is the study of humans, then why study non-humans? Well, there are several reasons. One is that they're our closest living kin. We do share a common ancestry, we do share a common ancestor. More on that next week. And by this proximity, having this much relationship with non-human primates, it offers us a window into our own evolutionary past. By observing primate behavior, by observing their anatomy, by observing the way that they interact with the environment, we can deduce the way that we may have interacted, how our behavior and how our intelligence may have evolved millions of years ago. Also, by offering clues into our own evolutionary past, we can get clues into the evolutionary process itself. And lastly, a huge component of primatology is conservation. Because many primates are under a threat of extinction, mainly due to our existence, understanding non-human primate behavior, the way they interact with their habitat, the way they interact with humans, can help us ensure their survival and hopefully mitigate their extinction. All right, let's look at the three categories also described in your books that primates fall under. Now, we have teased out specific anatomical traits, behavior traits based off of these three categories, which we'll get into shortly. But the three main categories, what qualifies, what primates do is that they are adapted for life in trees, they have a dietary plasticity, and they have a high degree of parental investment. So adapted for life in trees provides some unique anatomical features as well as dietary plasticity. Parental investment is more of a behavioral trait, and we'll talk about that in just a bit as well. So let's right now look at some anatomical traits, some life history traits, and some behavioral traits. This is going to be a little bit of a repeat of your reading. If you are fine, if you understand these really well, go ahead and just stick to the reading. I'm going to go over a few specific points with you. So as far as anatomical traits, we're going to look at a generalized body plan. We're going to look at hands, forward-facing eyes, generalized dentition, the protorsal bulla, and the postorbital bar. Let's go ahead and start. Let's look at generalized body plan. So most mammals have a specific type of body structure, specific type of morphology that allows them to thrive in specific environments. Now, primates are a little bit different. We have more versatility where some primates are niched or for a specific environment. They can also survive and thrive in a changed environment. For instance, an elephant may do really well on flat ground, but may not do as well if it had to climb trees. Primates, on the other hand, have this versatility where they can climb trees efficiently and move around large expanses of ground efficiently as well. This has really helped our survival. Now, with this generalized body plan, there's slight little tweaks here and there that allow us to be able to operate better in some environments than others. For instance, most primates are quadrupeds, and in quadrupeds we see a shift in the location of the scapula. The scapula is this flat bone, kind of a wing-like bone on your back. In quadrupeds, primates that use all four legs to move around, we see the scapula is placed more towards the side. We call this a lateral placed scapula. In bipeds, where we don't use our forelimbs as well as our hind limbs to move around, we see a scapula that's moved more towards the center of the back. We call this a medially placed scapula. Let's look at some other details of our body plan. Specifically, what I want to talk about is something called pre-adaptation. A pre-adaptation is a use of an organism's anatomical feature in a way unrelated to that feature's original function. For example, the vertebrae. The vertebrae's original function was to protect the spinal cord. And although it still serves that function, primates have also, as well as other animals, that use it for structural support and this vertical orientation to either be able to more efficiently move around on four legs, or us, where we have this S type shape to our vertebrae, allows us to more efficiently move around on two legs. All right, our hands. There are two distinguishing features about primate hands. One is that we have fingerprints. Fingerprints increase the surface area on our palms that not only help us be able to sense and touch the environment and be able to enhance sense of touch because we do use our hands to manipulate the environment quite a bit. But this increased surface area also seems to help us with gripping. Remember, life adapted in trees. Being able to grip is important. We also have an opposable helix, or opposable thumbs on our hands. This allows us again to be able to manipulate the environment as well as be able to efficiently and effectively move around on trees. Opposable helix is opposable thumb. Opposable pollex, which a lot of primates do have, is an opposable toe. Another feature about our hands are our nails instead of claws. Now this is slightly true. There are some primates that do have claws, or claw at least on one finger. But for the most part, primates have nails, which are made of the same material as claws, but they're shaped a little bit different. Forward-facing eyes. What forward-facing eyes allows us to have is called stereoscopic vision. What stereoscopic vision is the ability to see in 3D. Our depth perception is greatly enhanced by having both of our eyes on the anterior or forward section of our faces, forward-facing eyes. Now, along with stereoscopic vision, a cool thing about our eyes is that we have color vision. And we have pretty good color vision. Not the best, but mid-range, pretty good. And it seems like evolutionary this reliance on vision, having stereoscopic vision as well as color vision, has been favored in lieu of sense of smell. So we see a loss of our rhinarium. A rhinarium is basically that wet snout, the snout you see on a dog that allows it to be able to smell and take in more molecules of scent than we are. So we've lost our sense of scent, or sense of smelling, in favor of being able to see better. And there are several theories as to why this is. One is the arboreal hypothesis, posed by Frederick Wood Jones and George Eliot Smith. The arboreal hypothesis basically states that being able to have depth perception, being able to see color, helps us negotiate movement on trees better, and without it, we'd probably fall and not be able to do as well. Another theory as to why this is called the visual predation hypothesis. And the visual predation hypothesis states that forward-facing eyes allow us to become more efficient and effective hunters, where we're able to hone in on our prey. Matthew Cartmill points out that any species that is a predator usually has forward-facing eyes, whereas species that are usually prey have eyes on the sides of their head. All right, let's go ahead and move on. Generalized dentition. In generalized dentition, we are able to have different morphology on our teeth. Everyone has incisors, those front teeth of yours, next to canines, next to premolars, next to molars. And this generalized dentition, this different morphology in our teeth, is a reflection of generalized diet. And this generalized diet, being able to eat a large variety of food, has been largely helpful in our survival throughout the years. Our survival being the survival of our species and our lineage. All right, let's look at protorsal bulla. A protorsal bulla is a tiny little bit of bone that covers and protects the inner ear. Why would we need the inner ear protected? Think about it. Yep, you got it. For balance. Our balance is found inside our inner ear. So having a protection, again, adapted for life in trees, really helps us out being able to negotiate moving from branch to branch. Another bony protection we get is called the postorbital bar. And this postorbital bar encloses the eye orbit, provides protection, and not only provides protection, allows us to have good vision while eating. This would be important in areas where there's high competition within the species for food, as well as being able to avoid predators who are going to be trying to eat us. All right, so let's move away from anatomical features and look at some life history traits. Primates reproduce a lot slower than many other species. We give birth to usually single offspring at a time, although there are some species that give birth to twins more readily than others, and it takes a longer time for us to mature. mothers provide a lot of energy and a lot of time in raising their young. So primates are very, very case selective as far as their reproduction is concerned. And this other life history traits includes, and connected to this case selectivity, is we have larger brains. These larger brains are metabolically really expensive. They take a lot of calories to grow and maintain. And we're going to talk about this at a later date, but this is a sign that intelligence has significant evolutionary advantages. One interesting thing about primates is that although there are a lot of instinctual behaviors, we're also really good at learning behavior. And this has come in handy in order to be able to adapt to different environments. And being able to adapt to different environments has been the reason our species, Homo sapiens, has been able to basically dominate the world. And lastly, behavioral traits is that most primates are social. Why are we social? What does being social do? Well, it helps with survival. And we're going to talk more about sociality in the next lecture.